What is the vertex angle on number 1? Y. The vertex angle is the one that's always between the legs, between the two equal sides. Usually when they draw the picture, they put it at the top. This one they didn't. C. What is the base?
YX.
No. The base of the isosceles is ZX.
Wouldn't that be the hypotenuse?
On an isosceles triangle, it's called the base. On a right triangle, it's called the hypotenuse. So D, what is the hypotenuse of number 1? ZX. It's kind of a confusing question because it's both a right triangle and an isosceles triangle. The base of an isosceles triangle is the side that is not the two equal angles. The two equal sides. The two equal sides are called the legs. The other side is called the base. Usually they draw it differently. Number 5. Which triangle appears to be congruent to number 5? And C is correct. You gotta be kind of careful because they do look slightly different. But C is correct. Number 7. Name the congruent corresponding parts if triangle CAB is congruent to triangle TRS. What must the congruent parts be for those two triangles, for example? How many parts are congruent on those two triangles? 6. 3 pairs of angles, 3 pairs of sides, right? So for example, angle C on that triangle would have to be congruent to angle T on the other triangle. Angle A congruent to angle R, angle B congruent to angle S. What else is congruent? Side CA of the triangle. Now we didn't draw we don't have a picture of the triangle, but whatever CA is on the triangle, segment CA, that's going to be congruent to segment YX on the other triangle, right? So we're going to say segment CA is congruent to segment YX. What else? What other segments are congruent?
CA, TR, AB, RS, BC, SG.
Okay. AB.
Wait, are you looking at number 8 or number 7?
Which
number are we on?
Did I say the wrong thing?
Yeah, you're looking at number 8.
Yeah, I started looking at number 8, didn't I? So CA should match TR. AB should match RS. What else?
BC, SG,
Right, BC or CB.
and CA, TR.
CB should match TS. We know that without looking at a picture, just by looking at the congruent statement. Those segments would have to be congruent. And all the corresponding angles are congruent. Making 6 pairs of congruent things. You shouldn't have to look at the board for this one. You should just be able to look at number 7 and tell. You should have 6 pairs of congruent things. Number 8 is you're supposed to list all the ones that are true. So it could be more than one right answer. It's not just a multiple choice, really. Number 9, how many congruent statements are required to show that triangles are congruent using definition of congruent triangles?
3.
No. 3 is using like side angle side, that's a theorem. But using definition of congruent triangles, how many things did we have to prove were congruent? It's all 6. All 6 pairs. 3 pairs of sides, 3 pairs of angles. So the answer is 6. We had to prove 6 things were congruent to show. Because if the triangles are the same, all those
What about SSS?
parts. Okay, that's not definition of congruent triangles.
Right.
Side, side, side was a theorem. Yes, we only needed 3 parts for those theorems. Number 13, I guess. Actually, let's talk about number 12 a little bit. You see if I can draw that picture. Nice and pretty. Not really. But that's good enough. Alright, this is 7x plus 6. This is 4x plus 15. And that's all they tell us. So on number 12 it says find the measure of angle ACD. Oh, I told the other class wrong. Okay, I thought it said ACD. Okay, ACD is this one right here, right? If angle B is 21 degrees.
Oh. Well, we can find the x value by using the 7x plus 6.
Okay, how can we find the x value?
Well, that,
How are these three angles supposed to be related to each other? What kind of angle is this right here? If it's outside the triangle like this, what's it called? Exterior angle. What does an exterior angle have to do with these two angles?
create a straight line with that one line.
Okay, this was a theorem we learned. You guys need to know this. An exterior angle is equal to these two. Here's the way they say it. Exterior angle is equal to the sum of the remote interior angles. In other words, an exterior angle on a triangle is equal to the far angles added together. So this should equal that plus that. 7x plus 6 should equal 4x plus 15 plus 21. Alright, how do I solve that for x? Well, you do some algebra. Is x, do some algebra. Is x going to be the answer on this one? No, they asked for this angle right here. So once you get x, you need to plug it in right here to figure out what that angle is. Okay, I'm not going to give you time to do that though.
Wait, what number? Was this 12?
That was 12. 13 is we're using the same picture, but this time it says angle A is 59 degrees. So that would be this guy up here. They also tell us that angle A is 4x plus 15. So how can I use these two facts? The picture says 4x plus 15 is this angle. And then on number 13 it says this angle is also 59 degrees. So what can I do with that? The picture tells us this angle is this stuff. On the problem it said this angle is 59 degrees. So how are these two related? Okay, they're both this angle. So they both should be the same thing. This angle is 59, then 4x plus 15 should equal 59. And then we can solve for x in that case. On 13, it's looking for angle B, which is this angle down here. It's no longer 21. Okay, how do I solve this for x? Subtract 15, I get 44, divide by 4, x is 11.
So then you plug in that's 44 plus 6.
Okay,
That's up there.
if x is 11, let's see, what would this guy have to be out here? This one's 59, they told us that. 7 times 11 plus 6
83.
is, that would be 83.
So then that would mean that the interior angle is 97.
This would, yeah, this would be 180 minus 83, right? Right here.
Yeah.
So that would be 97. If this is 97 and this is 59, how do I find this angle?
You add them together and subtract it from
180 minus
Right.
180
180
minus.
minus these two. 97 plus 59 is 157. 180 minus 157. 23 degrees. Don't try using the numbers from 13 for number 12. They're different.
That's just
They're different problems. They're different numbers. On number 12, angle B was 21 degrees. Because they told us. On number 13, we just found out angle B is 23 degrees. They're just different things. Okay, number 15. Write expressions for the measures of angles 2 through 7. See if I can draw this well. Number 14 is almost identical to this. 14 though, yikes, that was a fail. Not great. All right. 1, 2, 3, 2, 4, 5, 6, 7. Okay, it tells us on the problem, measure of angle 1 equals x degrees. Alright, so this guy, let's get rid of that. That's x degrees. So how do I find the measure of angle 2? Right. If they make a line together, they're called a linear pair. You guys remember that? So if you do 180 minus this, you should get that. How do we do 180 minus x? We don't. We're not really solving this. We're just writing the answer in terms of x. Angle 2 would equal 180 minus x. Angle 3, angle 4, angle 5, 6, angle 7, and dot. Okay, if angle 2 is 180 minus x, this is 15, then what is angle 3? Do you guys see these marks right here on your book? They're congruent sides. So what do we know about isosceles triangles?
That if the sides are congruent,
The base angles are congruent. An isosceles triangle, which this is, if we got two congruent sides, the base angles are congruent. What are the base angles in this picture? They're across from the congruent side, so 2 and 3 are the base angles. So if 2 is 180 minus x, what do I know about angle 3? 180 minus x, they're the same.
This is number 14, right?
15.
Oh, that's
Okay, if angle 3 is 180 minus x, how can I find angle 4? If angle 3, whatever angle 3 is, how do I, if I knew angle 3, how would I find angle 4?
Wait, never mind, sorry.
Well, subtract it from 180.
So I was gonna
180,
say, but then, like,
180
180
minus this would equal this, right?
Yeah.
180 minus 180 minus x would give us that angle. What's 180 minus 180?
0.
Minus x,
Positive.
positive x. So angle 4 is x degrees. Didn't leave myself enough right there. So basically, 2 and 3 are the same thing, right? And this angle 1 and angle 4 are both supplements. Angle 1 is a supplement at angle 2, angle 4 is a supplement at angle 3. So 1 and 4 have to be the same thing. X degrees. Okay, if 4 is x degrees, how do I find 5 and 6? We make a different problem. we've done this before. Let's say I knew that angle 4 was, let's pretend it was 100 degrees. There. How did we find angle 5 and 6 back there?
Subtract that from 180, then you get 80, then you divide by 2, which
Right.
is 40.
5 and 6 are the same angles because they're the base angles on an isosceles triangle. So if we do 180 minus 100 is 80. That leaves 80 for these two, which are identical. So we do 80 divided by 2.
40.
Okay, so what if this angle is called x? How do we do this?
X divided by 2.
No.
X subtracted from 180.
180 minus
divided by
x divided by 2 will give us this. 180 minus x divided by 2. No, doesn't work.
2. And that'd be the same for 6 then.
Okay, yeah. 5 and 6, remember, are the same angles. So angle 6 is also 180 minus x divided by 2. Alright, and how do I find 7? Do these two add up to 180?
I was gonna have to know.
No, they don't make sense.
With a normal problem, you could add up 3 and 2, and then subtract that from 180.
Okay, we could do, you're saying it backwards, well, we could do 180 minus 2 plus 3, right? To get this, because it's the third angle in the triangle. That's one way to do it. There's another way that's probably easier to do, but harder to understand. So we'll do it that way. Yeah, let's see, what are 2 and 3? 180 minus x. Okay, we'll do it that way.
Let's do it.
What?
Can I close the vent? It's
Yep.
really cold. Thank you.
Just take your book and swipe that thing with your book.
It's easy.
Gracie might have to scooch a little.
I can just get up and go and do it. No worries. I got this. Yeah, man.
Just, if you're only 3 inches taller.
Yeah.
Alright. Forgot what I was doing. Yeah, that is a lot of work. Maybe you should do it the other way. Okay. What are these two things added together? What does that make? This is 2 and 3 right here. What's that plus that together? What's 180 plus 180? 360. What's negative x plus negative x? Negative 2x.
That
I don't
is.
remember doing this.
We did it with numbers, not letters. 14 is doing it with numbers, not letters.
Is it gonna do like this like that?
Probably 14 will, yeah. Probably not 15. 15 is definitely harder. Okay, because it's algebra, not just adding and subtracting. How does this simplify? What's 180 minus? If you are subtracting something in parentheses like this, you need to distribute the minus, right? You have to subtract 360 and you have to subtract minus 2x, which means you have to add 2x. What's 180 minus 360?
Negative 180.
Negative 180 plus 2x. That would be simplified. Or we could write it backwards, 2x minus 180. Whoopsie. I think I smell food.
Food sounds good right now.
Alright. Number 17. Okay, this will probably be more familiar because this is last week's stuff. If the triangle can be proved congruent, write a valid congruent statement and name the postulate or theorem that justifies it. What were the postulates or theorems that we used to prove triangles are congruent? Side angle side, side side side, angle side angle,
SSS.
Side, 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 did we say that one already?
AAS.
Hypotenuse.
Angle, angle, side, I think we said one twice. And hypotenuse leg. That was the last one. There's 5 of them. Side, 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 angle, side, angle, side, angle, 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 side, hypotenuse leg. Okay, so they asked us, anyway, let me keep reading. If triangles are not congruent, state an additional side or angle congruence that would enable the triangles to be proved congruent. On number 17, do we have enough information to say the triangles are congruent?
Yeah.
By what?
Angle, side.
No.
I mean, SSA.
Yeah. No, there's no angles.
What am I thinking?
Side, side, side. We know that AB is congruent to itself, so that counts as another side. So 17, by side, 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 we know the triangles are congruent. We also have to say a congruent statement. So triangle, let's say ADB is congruent to triangle what? ADB matches what?
BCA.
BCA. Those triangles are flipped around. A lot of times they're upside down from each other, right? So ADB matches BCA. Number 19. Do we have enough information to say those two triangles are congruent? No. Angle, angle, angle is not one of them, right? What other information would we need to be able to say the triangles were congruent? What's another thing? Archer?
ST is congruent to WB.
Yeah. If we knew one of the sides was congruent, then what would we have? Angle side angle, or angle angle side, either one. So we don't have to say that part. We just need to give an example. Like ST is congruent to WB. If we knew that, then we would know the triangles are congruent. Okay, on 20, I'm not going to do it, but if you look at 20, it says the lines are parallel, ACDB, ADCB. If the lines are parallel, we know that alternate interior angles are congruent. What would the alternate interior angles be? That would be like angle ACD and angle BDC. Those would be congruent if the top and bottom line are parallel. If the left and right line are parallel, angle ADC and angle BCD are congruent.
ASA.
So we have two pairs of congruent angles. 21, it says AB and CD bisect each other. What does that tell us?
Vertical angle.
If these two lines are bisecting each other, what does that mean? They're cutting each other in half, right? So this line is getting cut into 2 equal pieces, and this line is getting cut into 2 equal pieces. What else do we know that I didn't draw?
Vertical.
Vertical angles are congruent. So do we have enough to say the triangles are congruent?
Yeah.
Yes, by
SAS.
side angle side. Now we need a congruent statement. So let's go, actually somebody want to try this one?
22.
Not Will, not Archer. You guys already helped. For 22, or 21, a congruent statement. Okay,
Can you
Carson?
tell me how many there are?
The vertical angle.
No. We want a congruent statement
Oh,
about the
congruent
triangles.
statement.
About the triangles.
For the one we just did here.
Yeah. We don't have to say the vertical angles are congruent. We're not proving it. We're just saying we know it by a triangle congruent like this.
Corresponding
No.
parts.
Triangles are congruent. This thing right here.
Oh, okay. Triangle AEC is congruent to triangle BED.
AEC, AE matches BE, right? So congruent to BE. I can't never write that over there. All right, 22. This will be the last one we do today. It's a bit of a doozy. fit.
So, I have a question, real short.
Yeah.
Is half of this, like, due tomorrow, or is it all gonna be due on Thursday?
It's due on Thursday.
Okay.
Okay, tomorrow won't be as much because, well, tomorrow's Wednesday, so it's gonna be kind of a smaller deal. Let's see, 22 says prove the exterior angle theorem. Exterior angle theorem is an exterior angle of a triangle is equal to the sum of the remote interior angles. The exterior angle of a triangle, like angle 1, well, it kind of says it in the prove line. What are we trying to prove? That angle 1 is equal to angle A plus angle B. You guys see that in the picture?
Yeah.
We're trying to prove angle 1 is equal to angle A plus angle B. This is a theorem that we've had for a while now, but we're just going to prove it today. Prove that it actually is true. Okay, guess what line 1 is? The given. So,
How many lines are there?
I think it was like 5 or something. I can't remember. Yeah, this is definitely the biggest one I've assigned you guys is like a 4-line proof, right? A lot of them have been 3-line proofs. 5 lines would be maybe a little bit bigger than we can handle.
You're not giving us one of these on tests, right?
Absolutely.
He always does.
How about an 8-line proof next?
8-line
No.
proofs, yes.
I'm failing.
Give Will a 12-line proof.
Yes.
Every pun Will makes, add another line.
I don't know.
Why would punish me? That's
That's
another
6 lines.
Just don't give it to him. No,
I don't know if the proofs exist that are that big.
I'm sure
Make one.
there
Why would
are.
you punish me? Alright, did you guys write line 1 down already? No. I just copied it out of the book. Yeah?
One and angles of 1 and 2 together create 180.
Yeah, hold on, we're getting there. Where should I put this picture at? Let me draw a miniature version of the picture here in the corner.
I don't even know.
Okay, so let's start with this. What do I know about angles 1 and 2 in this picture?
They add up to 180.
Okay, I'm going to put it this way. Angle 1 and angle 2 are, what am I going to say? Supplementary.
Which is what corresponding is, right?
What? Corresponding? No. Corresponding means matching. Supplementary means adds up to 180. Why did we know those were supplementary? No.
What do you call that?
Linear pairs are supplementary. It's been a long time since we used that one. Linear pairs are supplementary. That's a theorem. I don't know. That might have been chapter 1 or 2 or something. We use that a lot, right? We always say it should add up to 180. We don't usually use the word linear pair though. Okay. I'm going to be a little more specific with that. I'm going to say, actually, I'm going to put my line 3 down here so I don't screw up my drawing. Alright. If 1 and 2 are supplementary, that means they add up to 180. So what should I put for the reason for that? Definition of supplementary. How did I know that was true? Because that's what supplementary means. Okay.
So it could be a 4-line proof if you didn't go into specifics.
Yeah, you could have skipped, well, we probably shouldn't have skipped line 2. Actually, I don't remember if it was 5, might be 6, possible. Kind of forgot. Let's keep going. So that's what we know about 2 and 1, they have to add up to 180. What do I know about angles 2 and angle A and angle B?
They add up to 180.
They also add up to 180. So that's what I'm gonna say now. Angle 2 plus angle A plus angle B equals 180. Why did we know that those?
All triangles add up to 180.
Yeah.
We would just write that or the shorthand.
Angles of a triangle add up to 180. That is a theorem. I don't know if it has a name or not, probably not. So we're just saying the rule. Angles of a triangle always add up to 180 degrees. Okay, this next line is probably the hardest one. See if you guys can figure out where I got it from.
I thought you said this was a 1.
Said
It's a
5.
five.
Actually, it's going to be more than that. I couldn't remember.
That's 1.
Okay, where did I get line 5 from?
If they both add up to 180, then they're equal.
Okay, yeah. Since these two add up to 180, then I can replace this with 1 plus 2, basically. What's it called when you replace stuff? Substitution.
Are we going to prove
No. Oh wait, yeah, actually. We are ready. You guys,
Is it 6?
you're not done until you get to the prove line.
If this is on the test, how many of these are going to be on the test?
7.
I'm failing. How many questions are on the test?
7.
Haven't made it yet. Alright,
Don't make it hard, please.
I'll try. How did I get line 6? What did I do?
If they both have angle 2 in it, then if you just take those away, then
What was that called when we took the same value from both sides of the equation? Subtracted the same values?
algebra.
It's an algebra trick, yeah. We did this addition postulate of equality. It's been a long time since we used that one. Addition postulate of equality.
Because that goes with adding and subtracting.
Yeah, adding and subtracting. Some books actually call it subtraction property of equality. This book calls both of them addition property of equality.
Wait, so we have 7 or not? And that's
We
it.
have 6.
When you say the line you're trying to prove, you're done.
Yep, sure.
And we are done now.
That was Emily's.
So nothing for today.
So tomorrow we just do 32 through 44.
My notes, you don't go over. That was it.
Yeah, we'll do the rest tomorrow. So try some of those evens. I'll pass the rest of these out.
I got the one.
11:35.
So we have a little more than 5 minutes.
Are you done? All right. If lines are parallel, and also that side.
Watch out. Can't see.
I don't care if you draw on your book,
Well,
but
serious.
as long as you erase it afterwards.
We're drawing.
Oh, I forgot to hit stop.